Like here we have matrix multiplication, inverses, and determinants. So it's really just a matrix day today. This is how the book teaches matrix multiplication, and it is absolutely correct. If you want to read all that and try to figure out all those symbols and letters and things, that's okay. But I'm just going to show you the next slide and let you kind of go from there. Okay, this says find A times B, and B times A if possible. And that's kind of what your directions in your book are going to say. First thing you have to do when you're solving or multiplying these things is check the dimensions. Like the dimensions of the first one is a 2 by 3. The second one is a 3 by 2. Because the two middle numbers are the same, because they're both 3, that means you are allowed to multiply them. You can only multiply matrices if the two dimensions in the middle are the same. Now the two outside dimensions, if the 2's, tell you what kind of answer you're going to get. So in this one, you're going to get a 2 by 2 when you multiply them. And for the first couple, I'm going to draw little blanks here to kind of guide you through there. And what you do is, you want to get this blank, the number that goes in this blank, you multiply the first row of this one times the first column of this one. So you're going to cross the first one and down the second one. So I'm going to do negative 2 times a 2, that's negative 4. I mean, I left enough room. 0 times negative 1 is 0, and 3 times 3 is 9. Notice I'm adding those numbers together. When you add those up, you get 5 in your first spot. Then on my second spot, this one right here, I'm still in the first row, but now I'm in the second column. So I'm going to do the first row of this one again, second column of this one. Negative 2 times 0, 0 times 0, and 3 times 3 is 9. So my second number here is 9. Now, when I get to this blank, I'm going to do the second row of this one times the first column of this one, because that's where this is located, second row, first column. 5 times 2 is 10, negative 7 times 1 is 7, 1 times 1 is 9. Add those up. I think that's 26. And then the last spot, the way I remember the last spot is I'm going to do the last row of this one times the last column of this one, or second row, second column. Go across, down. 5 times 0 is 0, negative 7 times 0, and 1 times 3. Add those together, you get 3. And what you have over here is your solution right there. That's what you get when you multiply those two. Now they also want you to multiply B times A. And because of, just for time's sake, I'm not going to do that. But what you have to do is realize two things. One, they're not commutative, which means you're not going to get the same answer, because when you switch them around, you're going to do if you put B first, you're doing a 2 by 3. If you put A second, you're doing a 2 by 3, which means you couldn't do that anyway, because the two middle numbers would not be the same. Those columns and those rows are not the same, so you couldn't do it. So we're going to put NP for not possible when that happens. Okay, the same, another one here. I already kind of worked it out, so I'm going to kind of just talk through real quick. That's a 2 by 3. That's a 3 by 2, so you are allowed to do it. And again, to get my first number right here, I did the first first row of that one times the first column of that one. And got negative 4, 0, and 27. I'm not sure what I'm looking at here. 2 by 3, 3 by 2. Okay, I'm not sure what's. That answer should be a 2 by 2. Like the first one, I think I must have skipped that. So I'm just going to go through really quick in my head here. I'm going to cross this first row, down this first column. Negative 2 times 2 is negative 4. 0 times negative 1. Let me get the pointer here. 0 times negative 1 is 0. 3 times 9 is 27. So I have negative 4 plus 27, which is 23. Okay, now I'm going to go first row, second column. Negative 2 times 0 is 0. 0 times 0 is 0. 3 times 3 is 9. So I'm going to get 9 right here. And keep going. Second row, first column. 5 times 2 is 10. 7, 9. 10 and 7 and 9 is 26. This might be the same one from the last problem. I think it was. This was confused me. And second row, last column. 5 times 0, 7 times 0, 1 times 3 is 3, and I get 3. I think that's the problem. Okay, then you do B times A, switch them around, and you would get a 3 by 2 times a 2 by 3, and do the same work, across, down, across, down, across, down. That's what you end up with. So sometimes you have to do both ways, and sometimes you can really just doing one. Directions here say about the system of equations is a matrix equation, A times X equals B. And that's as far as we're going. The directions in your book are going to say this also, because we did that last week, use Gauss-Jordan. We're not going to actually solve it using augmented, because I really want you to know how to set up a matrix equation. So what you do is you take all your coefficients, set that into one matrix, take your variables, put it in the next one, you're multiplying those, and take your constants over here, set them equal to a constant matrix. If you notice what happens here, that's a 3 by 3. That's a 3 by 1. And over here is a 3 by 1. And what's cool about that is you're allowed to multiply these two because the 3's are the same. And if you look at your outside numbers, it's a 3 and a 1, which is what you get. The other cool thing is if you go across and down like you're supposed to, you would get 1 times x1, negative 2 times x2, negative 3 times x3, and it would equal 9. And guess what? That's the first equation. So that's why you can set it up. And all we're going to do in your book when we get to this today is just set it up like that. We're not going to solve it. Thank goodness. All right, inverse of a square matrix. First of all, two matrices are inverses if you multiply them and you get what's called the identity. Identity looks like this right here, 1, 0, 0, 1, or 1, 0, 0, 0, 1, 0, 0, 0, 1. Mainly, if 1's in your main diagonal and 0's are everywhere else, that's what the identity looks like. And that's how, the only way you can tell if two matrices are inverses of each other is if you multiply them and you get the inverse. All right, so this one says determine, are they inverses, yes or no? So what I'm going to do is I'm going to multiply them. And you need dimensions. They're both 2 by 2, which means we are allowed to multiply, not because they're the same, but because those two numbers are the same. And so I'm going to multiply a times b here. I'm going to cross, remember, across this one, down this one, across, down, like we were doing a minute ago. Start with the first row, first column. 5 times 5 is 25. 6 times negative 4 is negative 24. Add them together, you get 1, which is what I was hoping. And I'm going to the second number, across the first row again, down the second column this time. 5 times negative 6 is negative 30. 6 times 5 is positive 30, so I get 0 again. Now I'm on the second row, so I'm going to go second row times first column. 4 times 5 is 20. 5 times negative 4 is negative 20, so I get 0 there. And I'm hoping I get 1 here when I do the last thing, and the last thing is the last row times the last column. So I'd say 4 times negative 6 is negative 24. 5 times 5 is 25. That's 1. So are they inverses? Yes, they are definitely, because I multiplied them and I got the identity. Okay, if a matrix does have an inverse, it's called invertible. I guess like inversible, but invertible. If it does not have one, it's called singular. You need to know that word especially. I'm not too worried about knowing invertible as much as singular. So if they ask you later, like, what's the inverse of this one? It does not have one, you're going to put it singular, no inverse. All right, find the inverse. If it doesn't have one, write singular. There's really a quick way to do this if it's a 2 by 2, and I'm going to show that to you on the next slide. I'm only going to do one of these because it does take a while if you don't do the shortcut. So just stay with me, because if it's not a 2 by 2, you do have to do it this way. So you do have to know what you're doing. But if it's a 2 by 2 like these two are, there is a shortcut, which I will show you in just a second, or after this problem. So what you do is you write the matrix as it is, negative 4, 6, 3, negative 5. And now beside it over here, you write the identity. It's 1, 0, 0, 1. What I'm going to do is put a little line in the middle there. You don't have to have that if you don't want to. But I'm going to turn this side, the side I started with, into the identity side, which is going to change that side into the inverse is what's going to happen. So what I want to happen first is, this goes back to the other day, I want that right there to become a 0. So I'm going to multiply the top row by 3, which would be negative 12, 18, 3, and 0. The bottom row by 4, make that 12, negative 20, 0, and 4. And I'm going to add those together. Add those numbers together. You would get, well, first of all, the first row I haven't changed yet. Oops, that's not a negative 6. That is a positive 6. Sorry about that. Positive 6, 1 and 0. Add the yellow numbers together. I got 0, negative 2, 6, and 4. All right, there's my line. Now I need that negative 2 to become a 1, so I'm going to divide the whole bottom row by negative 2. 0, 1, negative 3, negative 2. My top row is still the same. Negative 4, 6, 1, 0. Now what needs to happen is I need this I need that 6 to become a 0. So I'm going to multiply the bottom row by negative 6. 0, negative 6, 18, 12. Add that to the top row, which becomes negative 4, 0, 19, and 12. 0, 1, 18, oops, 0, 1, negative 3. Sorry about that. I'm looking at the yellow numbers. 0, 1, negative 3, negative 2. And then to finish up, I'm just going to divide that whole row by negative 4. Let me move this up a little bit. If you divide the whole row by negative 4, you get 1, 0, negative 19 fourths, 3, negative 3, 0, 1, negative 6, negative 2. Except that's a negative 3. I can't read my writing. This has been a great slide so far. And so your inverse would be the matrix that just contains these 4 numbers right here. All right. And I could have made a mistake right there the way that slide was going. I'm just going to go ahead real quick and show you the shortcut because it's so much better to do all that work. This is what the shortcut is, and this is what this is how your book describes it. I'm going to go through real quick what they're saying here. What you do first is you find the determinant, which we haven't done yet, so you know what that means. But anyway, that's how the book tells you how to do it. It's a good slide. You want to come back to that in a minute and read it again. But the steps are you find the determinant first. That's what this is. That's called determinant. Then you flip the determinant right there. Then you switch places with the first and fourth term. You change signs on the second and third. Sorry about that. That was a lot. Let me just show you. All right, here we go. This one right here. Find the inverse if you can. All you do is first of all, it says this. Find the determinant. The determinant of a 2 by 2, all you do is you multiply the two diagonals. You multiply this way, you multiply that way, then you subtract. So if I multiply the first way, you get negative 48. Multiply the other way, you get 48. If you do negative 48 minus 48, which you always subtract, you get negative 96. That number right there, that is the determinant. So that's the first answer. Then it says find the inverse. The shortcut for finding the inverse is this. You take the determinant, you do the reciprocal of it. You put it in the front. You take the numbers inside, you take the first number and the fourth number, and you switch places with those two. You take the second number and the third number, and you change the sign. And that's all you have to do. Now, they will want you to go ahead and distribute that negative 96. So you would get, let's see, 1296. I'm not going to take the time to reduce all that, but they do want you to multiply that through. Let me show you the next one real quick. Let's do this other one. You multiply this way, that's negative 4. Multiply that way, that's 6. Always subtract, that's negative 10. That number is your determinant, and that's the first answer. Then it says find the inverse. So you take the negative 10, and you flip it. You switch places with the first and the fourth number. You change signs on the second and third number. And then they just want you to distribute the 1/10. So you're getting 1/5 there, a negative 3/10 there. I'm trying to write it. Negative 1/5 there, and negative 1/5 there. And that would be the inverse of that. And if you wanted to check it, what you could do is you could multiply this one times the answer we just got, and you should get 1001. You should get the identity. All right, the determinant of a 3 by 3. There's two ways to do this. I guess I'm going to show you both ways. It'll be our last two slides, and we'll be done. The first way is what they show you right here. That's called expansion by minors. Or minors, so I guess it's a good way to do it. What we're going to do here to find the inverse is we're going to take what I think is, well, let's just do this. Let's take the top row. Let's take the second row. Take the easiest row you can find. This time it's the second row because the numbers are smaller. Pull the 1 out. When you pull the 1 out, that number, the 1 is in the second row in the first column. So ignore the second row and the first column and write the other 4 numbers, which would be a 1, a 2, a negative 1, and a 3. Now take the next number, take the 2, do the same thing. The 2 is in the second row, that row, and in the second column. So ignore those 2 and write down the 4 numbers that leaves. That leaves a 3, a 2, a 2, and a 3. And then do the same thing with the negative 1. The negative 1 is in the second row still, last column. So think about the 4 numbers that are left. That will leave a 3, a 1, a 2, and a negative 1. All right, now, here's the one thing you got to remember, makes this a little bit tough. If the number you put on the outside comes from an odd spot, and what I mean by odd spot is the 1 came from row 2, column 1. Since 2 plus 1 adds up to be an odd number, you must change the sign right there. The 2, right, this 2 right here came from the second row, second column. Because that's even, you don't change the sign, so you put a plus sign. The negative 1 came from second row, column 3. That's odd if you add them up, so you change the sign. And then you just work it out. Negative 1, do the determinant of those, which should be 3 minus negative 2. Take the 2, do the determinant here, 9 minus 4. Do the determinant here, negative 3 minus 2. All right. so I got negative 1 times 5, about put negative 5. I have 2 times 5, and then 1 times negative 5. So you just add all those up, and you would get negative 5 plus 10 minus 5, which would give you 0. So the determinant of that whole thing would be 0. That's of a 3 by 3. Now that's called expansion by minors, and you can pick any row you want to. Remember, the hard thing about that one is, remember when you change the sign, when you keep the sign the same. Last slide, finally. I think it's the same problem. I hope I get 0 again since I did that time. One more way you can do a 3 by 3, and it's called diagonals. What I'm going to do here is I'm going to recopy the first row here, recopy the second column here, and I'm going to use diagonals. I'm going to go diagonally this way, those two right there, the first 3, and I'm going to multiply. 3 times 2 times 3, that's 18. Put it there. Plus, do this diagonal. 2 times negative 1 times negative 1, that's negative 2. Plus this diagonal. 2 times 1 times negative 1, that's negative 2. Okay, now I'm going to start going backwards. I'm going to start with this 1 and go that way. 1 times 3, which is 3. Now when you get 3, when you start going that way, you start subtracting. And then I'm going to go here. 3 times negative 1 times negative 1, that's 3. But I'm going to put minus because I'm going that direction. One more. All the 2's right there. 2 times 2 times 2 is 8. And it's minus because I'm going that direction. So I'm going to add all that stuff up. 18 minus 2 is 16. Minus 2 is 14. Minus 3 is 11. Minus 3 is 8. Minus 8 is 0. Get the same answer again because it was the same problem. I was hoping I would. And that's expansion by minors. Now, I'm going to give that's called using diagonals. And I'm going to kind of leave that up to you which way you want to go with that. You can do diagonals or the minors either way. Quite a bit of stuff today, not hard. None of it's really that hard. Just a lot of different things with matrices, and hopefully it wasn't too bad. I'll see you in class tomorrow and we'll clean it all up. So, see you then.